Alright, so this is a video editorial for the LeetCode Biweekly Contest 176. Wait, why? Okay, yeah. This is a video editorial for the LeetCode Biweekly Contest 176. This contest was like pretty bottom heavy. The first three problems were extremely easy. And Q4 it has some interesting ideas. I cheated it using some data structure, but there are like here, instead of knowing like the implementation, the idea actually is more important for Q4. So I'll be going through the approaches which I implemented during the contest, and I'll explain them. And after this, after my explanations, you can see me solving. You can see my live recordings. And the reason I took some time to get started was because, as usual, the bi-weekly pages weren't loading. It was throwing like not found, which is a recurring occurrence. So, all right, let's get into Q1 first. Q1 was a three-pointer, so as expected, it's like you just have to implement what they're asking of you. Basically, we're given a array of strings, a vector of strings, and we are given weights of every character. Like, so this is a size 26 array where weights I is the weight of the ith character, and the weight of the word is the sum of all the weights, right? So we have to calculate the sum, and we have to map this to a character. So ideally, like oh my bad, ideally what we would do is 0 to, since we are mapping this modulo as 26, 0 to 25 would be A to Z, right? But it's asking us to do the reverse, right? Which I misread. I was wondering why my solution was wrong. So we have to reverse this, and for reversing we can just do this. Sum is equal to 25 minus sum. So if we do this, my bad, if we do this, 0 will become 25, 1 will become 24, and so on. 24 becomes 1, and 25 becomes 0, which is the reverse mapping the problem demands of us, right? So we can just do this and push back this and then return this. So this was a straightforward problem. There's no need to dwell on this. Q2 was all right. It said like I read the problem name and I thought DSU, right, because connected components, connected groups, but it's way easier than that. Ignoring the wrong answer because I misread the problem again. This is way easier than that. Basically, we're given again a vector of strings. Vector of strings is a recurring theme in this contest for some reason. We are given a vector of strings and we have to basically form connected groups, and a group is connected based on this k. And k is stating the size of the prefix. Like if k is 2 and all the strings where the 2 length prefix is the same are connected. So for example, here k is 2, we have apple and apply, and its 2 length prefixes ap and ap, right? So these two would be a part of the same component. Similarly here we have banana and bandit, so since 2 size prefix is ba, these two are the same component, and so on. So at the end we have to return the number of connected groups that have at least 2 words, return their count, right? Also this thing which I missed, words with less than length k cannot join any group are ignored. This was my fail, like the reason for my wrong answer. So obviously here what we can do is since a group is uniquely identified by the prefix, for every string we can find its prefix, and since we only care about our prefix, right, so assume there we have 2 strings a, b, c and whatever, and then a, b, c and then something else. These two are different, by the way. And if k is equal to 3, since the 3 length prefix is same, fundamentally these two strings will belong to the same prefix. And since we don't need to know the actual strings which are a part of a component, right? We only need to know their count. So my idea was, okay, we'll take the prefix and we'll implement the count in a map or whatever for the set prefix, like ABC in the map will get plus plus for every occurrence of this prefix, and then at the end we'll iterate on all prefixes, whichever has frequency greater than equal to 2, we'll do res plus plus for those, if this is true. So yeah, this was the implementation. Beware of this, the words with less than k cannot join any group. So if, for example, if we have a, b, c and then length is less than k, this is k, till here is k, and we have some characters and we have the same string here, these two will get mapped to the same thing here, right? And in the final counting, once we check this is greater than equal to 2, once we check this, it will increment the result, right? Which will give us over counting, which we don't want. So we have to do this check as well. So the implementation was straightforward. If first ensure that the length is greater than equal to k, which cost me a wrong answer. This, yeah, you could see me solving this live. You could see this mistake. It's not loading for some reason, but yeah, we get the size k prefix and we increment it, and then for all prefixes, if the frequency is greater than equal to 2, we add it to this and we return the rest. So this was straightforward. It's not loading. Okay, all right. Yeah, this was, I was overcounting here. So yeah, question 3 was a variation of the house robber problem. If you know house robber, then this should have been an instant solve more or less. House robber is basically a problem where you are given houses. Houses are values in an array. Basically, houses are indices, and the values in the array are the value of the house, the goods stored in the house. So the robber can steal from the houses, but the only condition is that if he is stealing something from I, then they cannot steal from I plus 1. They have to skip a house, right? They have to skip an adjacent house. So this is your standard vanilla house robber, and the extension we have is we are given another array colors, and the only extra condition here is we cannot rob two adjacent houses if they share the same color. Like if this is A, this is also A. Colors are, I guess, numbers, not, yeah, colors are numbers, my bad. If this is 1 and this is also 1, then we cannot rob this. But if this is 1, this were 2, then we would be able to rob this in this variation of house robber. Again, I took some time to solve this because I thought that like if this is 1, this is 1, we rob this, then we cannot rob this as well. I initially thought this, but the problem explicitly states that adjacent houses, right? And in one example also they clarified this, like here we can steal 10, 3 and 9, even though 10 and 3 both have the one color, right? This example clarified this. So yeah, basically then you can just again, if you don't know house robber, it's basically a standard DP problem, because for the standard house robber, if we are at I, either we steal from this and then the best answer is from here, right? If DPI is the best answer for the suffix starting from I, like for this region, if we steal at I, we cannot steal from this, right? So then DPI would become, if we are stealing from this, nums I plus DP I plus 2, right? The answer, this is I plus 2. Either this, or if we don't steal from this, then we can directly get the answer from here. So it says DP I plus 1. So it's a max of this since we want to maximize. And here, instead of we just add another condition, we first check the colors. If the colors are different, then we can just do this. DPI is equal to nums I plus DPI plus 1, since we don't care about the stuff, right? And if the colors are same, then we do this, the house robber thing. So this was the straightforward solution. If the colors are the same, again, obviously the last value nums n minus 1, it's a straightforward base case. Here if the colors of the adjacent houses are same, then we do the house robber constraint regulation, transition, which I described. Else we do this, because we can just, if like assume all the colors are different, we have 1, 2, 3, 4, 5, all colors are different, then we can simply rob all the houses consecutively, right? And in that case, the sum would become this. And at the end, we return dp0, since that's the answer of the entire array. Again, this is 1e O of n. Yeah, O of n, straightforward. And this was Q4. So yeah. Instead of looking at my implementation, I'll explain you the overall idea, because I did something else. I wanted to save time, so I used something else. I'll tell you afterwards. So basically the problem states that we are given a tree. Let's assume some tree. And every node in this tree has a character assigned to it. Characters can be obviously from A to Z. So like assume we have A here, B here, B here, C here, A here, B here, C here, D here, D here, and A here. So we are given these nodes, and we are given a character assigned to every node. Now we can perform the two types of queries would be performed on this tree. The first query is we would be given a node, and we would be asked to update a character present at this node to something else. So like if this is A, it can be updated to some B or C or whatever character in this range. And the other query is the thing which we want to return in an array. Is that we would be given two nodes, let this and this, and then in the shortest path connecting these two nodes. So the path would be this, right? This. We have to check if the characters can be rearranged to form a palindrome. So now this is already a subproblem, right? Given a string, how can you tell if the characters can be rearranged to form a palindrome? This is a fairly common subproblem. So this string cannot be rearranged to form a palindrome. But if this were B, or let's say if this were A, then this would be possible, right? We could make this B, 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 A, and then B, B, which is a palindrome. So like if you can think about this for a second, but the main result, the idea is if the number of characters or whatever elements with odd frequency is less than equal to 1, then we can form a palindrome. Because if all characters were even, we can obviously form a palindrome, because assume the line of symmetry, the elements on the left and right, we can just split them equally, right? So it would always form an even palindrome, and when we have one character with odd frequency, we can place that odd frequency in the middle, let's say A in the middle, and then all characters with even frequencies can be placed about them. So this would remain a palindrome. So yeah, so now the problem, we have modified the problem. Instead of worrying about rearrangements and strings and characters and palindromes, what we need to do is, given a path, we only need to find the count of elements with odd frequency. And if that count is less than or equal to 1, then yes, this path, the characters can be rearranged to form a palindrome, else it's impossible. And at the same time, we also need to take care of the updates. So like for problems like this, I'd suggest handling the queries first, because updates more often than not lead into the queries. They are dependent on the query. So here for the query, there is a problem on LeetCode which I had solved earlier. It involved this as a subproblem. Basically, you are given a tree and you have to basically, I guess, count the number of such paths, and there were no updates. So for my intuition was during the contest, basically, since we only care about the frequency data, and even in the frequency we don't care about the exact frequency, we care about the parity of the frequency, and the parity is just 0 or 1, which is, this is even and odd, right, or odd. So my idea is, since we only have 26 characters, this is 6, since we only have 26 characters, if we had a mask of the character, where if the bit was set, it would tell us that this character has an odd frequency, and if the bit were unset, that would mean this character is an even frequency. So like here, let's let all the D's we see here. So we only have 3 characters. So for B, the mask would be 0, 1, 0. For this B, it would be 0, 1, 0 as well. And for this A, it would be 0, 0, 1. This is LSP, this is MSP. For this path, if we take the XOR, what would be the XOR? It would be 0, 1, 0, 0, 1, 0, and 0, 0, 1, right? If we XOR all of this, it would become 0, 0, 1. And the resulting characters which we have would be B, B, A. The B weight is 0 since its parity is even, right? We have 2 B's, and A's bit is 1 since we have the parity as odd. Its parity is odd since it only has 1 occurrence. And in fact, this can be rearranged to form a palindrome, BAB. If I were to take another example, let this be A and this be B. Similarly, our XOR would become, all of the elements would become 0, right? This 0, 0, 1 gets cancelled using this. And actually, the resulting XOR would be 0, 1, 0. These two would get cancelled, these two would get cancelled, and we would only have this 0, 1, 0 remaining. And in this case as well, we could form a palindrome since the characters which we will be having will be A, B, B, A, B, right? So A, B, B, A, B. And this can be rearranged to form this A, B, 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 A, which is a palindrome. I circled the wrong thing, which is a palindrome. So now the problem, we have again compressed the problem. After compression, the problem now becomes, given this, first of all, we don't care about the character. Like if we are given some character X, what we will do is we will first get its weight. So X minus this A, which will give us some number, right? And now we would do this for the mask. This will give us some mask, right? Since for A, it's A minus A, this is 0, and 1 left shift 0 is 1, so this becomes 1. Similarly, this is 1 left shift 1, which is 2, right? So this becomes this mask. This is just for finding the masks. Now what we care about the XOR of the elements in the path. We are now, the query which we want to handle is, given some values, we don't care about the characters now. Given some values, what we want to do is, we want for some 2 elements, we want to find, for some 2 nodes, we want to find the XOR of all the nodes present in its path. So if we were queried this and this, we would want to find this, XOR this, XOR this, XOR this, XOR this, XOR this. And then we would receive some arbitrary XOR Let this be the XOR. Now, here we know we have 4-bit set, which means 4 elements will have an odd frequency. But our palindrome condition was only one element, at most one element can have an odd frequency, right? And since 4 is greater than 1, it's not possible to form a palindrome for this path. So we need to worry about finding this XOR quickly of the path, and at the same time we have updates. So here we have two approaches. What I did during the contest is I used HLD, which is heavy light decomposition, which is a common technique for running node queries on a tree while with updates. And this is 100% overkill for the problem. My solution was q into log square n, yeah. But you can easily solve this problem without using it. I wanted to solve it fast since HLD has a straightforward template which you apply. I wanted to solve it quick because I had already made the mistake in a previous problem, right? I wanted to make up for the time. So I used HLD and solved this in O of n log n plus q log square n. You can solve this in n log n plus q log n. If instead of HLD, what you do is you use prefix sum and Fenwick trees. HLD approach is nothing, it's just copy pasting a template, so I won't elaborate on that. But for the prefix sum approach, I'll give you an idea if you want to solve it using this. Assume we have some tree. Yeah, we have this tree. Now we assume we want to query the XOR from this node. I'll darken the nodes. We want to know the XOR of these nodes, right? So we would be given u, v, and we want to know the XOR of this path. So for for destructive functions or like invertible, like XOR is destructive and sum, this would work for sum as well if we wanted to query the sum. What was the writing? Yeah, destructive. For destructive functions or invertible functions, what we can do is, if let's say we know the XOR from the root to this node, and we know the XOR from the root to this node as well. If we XORed these both, what would happen? This region would get removed entirely since it's coming twice in the XOR, right? We would be left with this, and this, and then we can just XOR this extra part here. Again, so like if I were to explain, let this be x, then this be a, b, c, d, and e. So if we know the XOR from the root to u, which is a XOR b XOR c, and the XOR from root to v, which is a XOR b XOR d XOR e. And if we XORed these both, since XOR is destructive, this portion would get removed and we would be left with c XOR d XOR e. And what we wanted was, we just wanted b XOR b, right? So we can XOR b here again, which is a single node, so this is easy to get, and we would be with our desired outcome, right? And if we observe the XOR which we will need to add again is the LCA of u and v, right? So here another problem, we want to find the LCA efficiently, which can be, if you don't know this, then you'll have to look this up. I won't be explaining this in detail. For finding LCA of two nodes in log n, you can use binary lifting. So that would give us the LCA, so which will be used for XORing this b again. And for finding the path XORs, the idea is, I'll undo some stuff. I think this is sufficient. Yeah. The idea for finding path XORs is, assume there were no updates for now. For updates, I'll just give you a simple transformation. For no updates, what we do is, assume I'll add some arbitrary XORs again, b, c, d, e, f, g, this is g, h, I, and j. We wanted to know the XOR from this u, from the root. This is root, let 0 be root. So the method for doing this is, we do a sort of a Euler tour of the tree. The Euler tour is basically we visit every node in this fashion. We visit all the nodes in this fashion. This is a Euler tour. So visiting these nodes, what we do is, when we enter a node, we'll add this. We'll do XOR A, then we'll do XOR B, then we'll do XOR C. Right? We have reached this node, and the prefix, the XOR of this path is XOR A, XOR B, XOR C, right? Which is correct. The XOR of the A to B is XOR A, XOR B. So we'll be storing these values in some array or whatever. Now when we are going up, we'll XOR it with the same node again. So this thing gets removed. So when we are coming up till here, we have XOR A, XOR B. Now when we go up again, we'll XOR B again. So we'll be only left with XOR A. Now when we go down, we XOR D. So it becomes XOR A, XOR D, which if you see is the XOR from the root to D, right? Then we'll XOR A, E again. So we'll get this XOR. So using this, you can actually get the actual prefix XORs from the root to a node, any node. And since we have the prefix XOR, the problem is like trivially solved. And to introduce what do we call updates, we can just, instead of using prefix sum arrays or prefix XOR arrays, we can just use a fenwick tree for introducing updates in this. And this was the problem. This might feel a bit overwhelming, and I was like, instead of giving you the solution, I'm just giving you minute ideas here, the smaller ideas which are used to solve this problem. Because like the reason I was able to solve this was because these types of problems used to appear in contests. Like there was a time period where like 5 or 4 contests had consecutive tree query problems, so I had to practice a lot for solving this. And even I couldn't solve them on my first attempt, so don't get like demotivated or something if you weren't able to solve this. Alright, yeah. So this were my explainers. If you wanted me to explain this HLD code, but it's like fairly straightforward. It's just you build the thing. This is me making the graph, and this is me creating the masks. You call this function, such as this is a black box. It will return us with the queries. And for some reason, the queries were given as a single string, so I had to parse them as well. After parsing, if it's an update query, we update. Or else if we query, we get the count of the set bits, and if it's greater than or equal to 1, it's less than or equal to 1, then it's true, else it's false. So I just did that. And yeah. Alright, so yeah, you can watch me solve this contest live in the next section of the video. Bye. Seven, okay. Okay, house over 5, okay. Okay. 7 pointer. लोड हो जाएगा कुछ. वाह. Hmm. DSU से स्पैम कर दो भाई, दिमाग मत लगाओ। सॉर्ट करके कर सकता है लेकिन ओके। Hmm. It doesn't matter. I literally, what the fuck is this? HLD करूँ क्या? HLD स्पैम कर सकता हूँ, पता बहुत बड़ी बकचोदी करके HLD कर सकता हूँ इसको। जल्दी से लगाया इसको पास करी सेगमेंट क्या चाहिए। और मैं बिना HLD के हो सकता है, यहाँ से मेरे प्रीफिक्स है। इसे वापस ऐड कर दूँगा अलग से, हो गया। सेगमेंट्री कहाँ है? लीजिए अपना लीजिए। Oh shit, my bad. क्या है भाई? अरे भाई रे, माफ कर दे। चल जा भाई, ये इतना टाइम क्यों लगाता है? अरे यार, अब क्या बनौती है? नो मैचिंग फंक्शन के साथ टू स्ट्रिंग नहीं होगा, तो ही होगा ना। मैं रिटर्न इनपुट ऐसा क्यों दिया है? पागल पागल है क्या? फालतू में, मतलब नो रीज़न टू डू ऑल दैट। अपना HLD ये जोर दे रहा है। ओ माय फकिंग गॉड भाई, ये क्या हो गए हैं? तू चला जा. Please, I need this. LeetCode. I need this. False, false, true. We have true, false. Printed. See out है सिर्फ इधर और उधर. डेली वाला मैं रेज करूँगा. यस चलेगा.